At this point, you've learned how you can add SwiftUI views to your app, either visually using the SwiftUI canvas or by tweaking the Swift code itself. It's time to take a deeper look at the code that you use to create SwiftUI views and views modifiers. But before you do that, it's important to understand some programming theory about how all this works. In this episode, you'll learn about 3 key concepts of programming in Swift: instances, data, and methods. Then, we'll take a deeper look at the code that the SwiftUI canvas generated for you. Now, if you're already familiar with the concepts of classes, structs, instances, properties, and methods, and you feel comfortable with the SwiftUI code that you've seen so far, feel free to skip this episode. When you're developing an app, programmers like to group related data and functionality into small pieces. For example, let's say you wanted to display a list of dogs in your app. To do this, you'd first define a template for what you need to know about each dog, such as perhaps its name or its breed. Once you have that template, you can create multiple instances of that template. You can think of instances as just filled-in versions of those templates. For example, you might create an instance for Dusty the Poodle, or an instance for Scampy the Maltese. There are 2 main ways to define these templates in Swift. You can either use the keyword class, or you can use the keyword struct. In some programming languages, class and struct are radically different in functionality. Usually you can do a lot more with classes than you can with structs. But in Swift, structs are very powerful and full-featured, so the differences between the 2 are a lot more subtle. You'll learn more about the differences between classes and structs in the course Programming in Swift Fundamentals. But you don't need to worry much about the differences between the 2 in this course. For now, just think of classes and structs as fairly interchangeable, and for this course, we'll be working mostly with structs. You can think of your Swift app as a bunch of instances of classes or struct templates that communicate with each other. And believe it or not, you already have experience with both instantiating templates and creating your own templates already. For instantiating templates, think back to how you created an instance of the button template. You also created an instance of the text template that says "hit me," which you put inside the button instance. You also created your own template. Think back to how you created your own struct called content view, and you defined what its body should look like. As you can see, iOS provides many templates for you, such as the button or text views, and sometimes you have to create your own, like you did for the content view. A class or a struct, or an instance of a class or a struct, can have both data and functionality. For example, let's think about the Hit Me button in your app. First, the Hit Me button has some data, such as the view to display inside, the position on the screen, its width and height, and so on. Second, it has some functionality, such as the ability to recognize when the user taps on it, highlight itself when tapped, and trigger an action in response. The part that provides functionality is commonly called a method. You'll also see the term function used in Swift. A method is simply a function that belongs to an instance. You've already used a few methods in Bullseye so far. Remember when you made the text view bold and set its kerning? Those were examples of calling a method on the text instance. You can tell when you're calling a method because the syntax to call a method is to take the instance, put a period, then put the name of the method. Afterwards, you put parentheses, and then any parameters to the method, which you can think of as input to the method. The first method here, bold, takes no parameters. But the second method, kerning, takes 1 parameter, which is the kerning that you want to apply between the characters. The methods you've used so far, like bold or kerning, have been written for you by the engineers at Apple. Later on in this course, you'll learn how you can write your own methods too. The concept of methods may still feel a little bit weird for you, so let's take a look at an example. You, or at least an instance named you, want to throw a party. You clean the room, you put on some music, but you forgot to buy some cookies. Fortunately, you've invited the instance named Steve, who happens to live next door to a convenience store. So you call a method on Steve, asking him to please bring you some cookies. The computer now switches to the instance of Steve and executes the commands from his buy cookies method, one by one, from top to bottom. When the buy cookies method is done, the computer returns to your throw party method and continues with that, so you and your friends can eat the cookies that Steve brought back with him. The Steve instance also has data. Before he goes to the store, he has some money. After he exchanges the money for other, much more important data, cookies. After making that transaction, he brings the cookies back over to the party, and you add them to your drink and snack table. If he eats the cookies along the way, well, your program has a bug. Finally, let's talk about data and properties. Throughout this video, I've been using the term data to refer to information an instance needs to do its job. In Swift, the way you store data on an instance is through something called a property. And there are two main types of properties provided by Swift. First, there are stored properties. This is when you want the instance to simply store a piece of data for you, like the subtotal of a bill, or the tax that you need to pay. Second, there are computed properties. This is when you want an instance to run some code that you write in order to calculate a piece of data. For example, you might want to make a computed property calculate the total bill based on the subtotal and tax stored properties that you created earlier. Okay, that was a lot. Let's review some key points. The most important thing to remember from this lecture is that your app is made up into instances of class and structs and that they contain two things. First, they create data, like the money to buy ice cream with. And second, they create methods, like the steps involved in buying some ice cream. Instances can look at each other's data, well, to some extent at least. After all, Steve may not approve of it if you peek inside his wallet. You can also ask other instances to perform their methods, like how you ask the text views to set their font's weight to bold. Asking instances to perform their methods is how you get your app to do things. Let's take a deeper look at the code that we've written so far. You'll see that it already includes examples of instances, data, and methods. Let's start with instances. Here we're defining a template for an instance using the struct keyword called content view. You can say this in plain English as, we're defining a template for an instance called content view that is a view. Now, if we switch to bullseyeapp.swift, here's the line that creates an instance of a content view based on that template. Now let's move on to properties. Back in contentview.swift, we can see that content view defines a property called body on this line. So body is a property of type SomeView. Again, the body is the main view, and it can contain views inside it, such as the VStack, which then contains a text and a slider, and so on. Var here is short for variable, which means two things. Number one, it's a container for data, and number two, its contents can change. So this line, when translated to Swift to plain English, means this is the definition for a variable called body, and it's a SomeView. So basically, this is letting content view know what to display as its main body, which is all of the views you can see on the screen inside a VStack. Unlike content view, whose definition says that it's a view, the definition of body says that it's a SomeView. The sum in front of view broadens the possibilities for body. Without getting into too much detail for now, this means that body can either contain a view or something that behaves like a view. This means that it could be an instance that isn't exactly like a view, but it has the same properties and methods as view. The contents of body are defined by these lines here. And in particular, all of the lines here where we're applying view modifiers are examples of calling methods. For example, this first line here called the text object's bold method. When you call this method, bold bolds the text and returns a new, bolder text instance. Similarly, these are all other examples of calling methods on whatever we return from the previous lines. And as you can see, some of these view modifiers pass values to the methods, which, as I mentioned earlier, are called parameters. For example, here we pass the parameter or value 2.0 to the kerning method. All right, as you've seen, you already have some experience working with instances, data, and methods, and Swift UI. First, you have experience with instances. For example, you've created, or as programmers would say, instantiated, an instance of the content view struct to display a bunch of views on your screen. Second, you have experience with data. For example, you've created a body property that keeps track of an important piece of data for the content view. That is, the view to display on the screen. And that view is basically a VStack with a bunch of other views inside it. Finally, you have some experience with methods. You called several methods on the text instance, including bold, kerning, and many more. Wow, this was a lot to cover in just one video. Don't worry if you didn't get everything right away, or if you had trouble understanding some of the syntax or terminology. There's a lot of concepts here that may be new to you. We'll review these concepts again and again throughout this course and throughout the rest of the courses in our learning path until they begin to feel like second nature. Again, it's all about learning via repetition.